A very good day, dear students. I hope you all have enjoyed the previous class. That was our first introductory session on the subject of robotics. So again, I'm here to teach you with this wonderful session. That is the second session, which I call the robo anatomy. In few seconds, in few minutes, you'll get to know why I'm calling this. So I'm Shomodip, your faculty for robotics is here with you. Let us begin our today's session. We have already gone under the water. As you can see, the submergible robot is here and working under the ocean. Okay, so you might have seen this in any videos or any kind of programs. And in our first class also, I've shown you this robot, right? Big classification based on the purpose for which we are using a robot, right? So now let us start our session. Let us see what we can know before directly going into the programming parts, before directly going into the nitty-gritties of the microcontroller, of the sensors, of the power supplies and everything. What else can we talk about robotics, or specifically a robot? Okay, let us see. So here we are to study the chapter 2. That is our second session in robo anatomy. Now, we all need to understand something very, very clearly, dear students. And what is that? See, I believe in grasping the basic concepts very well. You see, if the foundation gets strong, the building above gets strong. So, your foundation, that is the understanding of this topic of robotics, of this subject of robotics, whatever you might say, should be very, very firm, should be very, very strong itself, right? Hence, I have designed, as I promised you, we will be going from scratch level to difficult project level. Hence, I have designed this whole session in such a way that we can cover the most basic topics and then we can go to the difficult topics, right? So, anatomy. What we mean by anatomy? We generally not define the topic of anatomy while studying robotics, but trust me, it's important to know about it. You see, all the artificial things that we have made till date, right? It is somehow or the other inspired by our natural things, right? Somehow or the other, it is inspired by the natural thing. A very simple example, you can take aeroplanes, you can take the examples of helicopters, any flying machines. Obviously, by seeing the structure of the aeroplane, you can understand from where it is being inspired, from birds, right? Right, the structure is inspired from bird itself. Now every other thing, it is inspired from some of the natural phenomena. Now try to understand. So we have a thinker bot over here, right? A thinker android who is thinking about it. So you guys also think. When we are talking about a robot, we can classify the whole robot into various parts. We can classify it into the moving parts. We can classify it into controllers, right? What are the controllers? They are basically the brain, we can say, right? We'll come to that later. Don't worry. We have a separate session, separate class for that. So let us go into the anatomy part, basically, and let us see what we are seeing over here. The thinker is thinking, what is the purpose of a robot? When you build a robot, we have a purpose. What is that purpose? You see, every robot build has a purpose of their own, and to know the purpose, the build, the parts, and whatever the proceedings might be, it has to be, and it can be studied in such a manner that we can understand those things. For example, at first I have shown you an underwater robot that is searching and that is repairing some of the pipelines, underwater oceanic pipelines. Now try to understand, dear students, when a human being or some task related to a human effort, we are using it, there is always life hazard. Going inside the ocean, tackling the tremendous pressure, there is always a life hazard associated with it, right? So why not let us make a robot who can travel to the depths of the ocean and can tackle that pressure? Why not build a robot who can go into the sewer system and clean it, or any clogging has happened, can fix it? Why not do so? Why not build a robot to fight fire hazards, to fight forest fires, to fight some incidents, some bad incidents, accidents might have happened? Why not build a robot? Wherever there is a chance of human being getting harmed, why not associate a robot with that? So that is the basic purpose. That is the sole purpose, right? To every purpose, to every need of human being, something or the other can be made. A very good example, I am teaching you in this online mode, right? So this is also some machines, some robots, some code, some programming, some algorithms working all together to serve you. I cannot meet you in person, right? But I'm serving you in an online mode, right? So for every need, we can build something. That's a great thing, right? So that is what I was talking about, the purpose of it. Now let us move on. Let us say human anatomy. Now, don't get scared by the picture because we all are the same from inside, right? So if we look into the human anatomy, now why you might be wondering, so why we are studying human anatomy in a robotics class? Trust me, it is very important. How it is important, dear students? When we see the human anatomy closely, we can see each and every robot that we make, each and every actuator, each and every gripping part, each and every moving part, each and every joint, limbs, links, anything we make, primarily it is inspired from the human body itself. You might wonder how. Try to understand. Have you seen a very simple arm robot, right? The picker robot, who picks something and places something. It is very popularly, it is inspired by our design of the human limb or human arm. It is the gripper over here, which grips the substance. It can grip some substance, right? It can grip some substance. There is a joint over here. The joint can move. It might rotate, it might elongate, right? There is a joint over here. So these are the joints basically. And this part is the link, right? This part is link. Okay. This is called the end effector. So you see, the simple robot, the simple thing, it is also inspired from human arms. Walking robot, of course, you may wonder. You can think of like how it is inspired from. So basically, if you see the skeletal structure of human body, the skeletal structure, the limbs, how two bones are joined with each other, okay, with the help of the ligaments, and in between there is the cartilage. We have studied those in our school days, right? So how the bones are linked with each other, how the muscles are linked with each other, how the bones move. Study of joints is a very important part, right? So human anatomy very infamously inspires the build of any robot. Now, what are the most important parts of a human body if we see from outside? What are the most important parts we can say? We can say our eyes are very important, very, very important. One of the most important organ, right? We see the sense organs we study in our childhood, our eyes, our ear for the auditory purpose, right? To hear something. I'm teaching you. How are you hearing it? Through your ears. Okay. The limbs, we move, right? We move, we can hold, we can grip, we can walk, right? Our limbs. I've just given some of the examples of the parts. Now, if we draw an analogy, a very simple analogy, dear students, with these parts to the robotic parts, what we get? In place of the eye, the robot can have a camera. It can be of any shape and size. The specific function of a camera is basically to see or record things, which our eye does, inspired by human beings. Understood? Or rather, I should say, inspired by natural or living things, right? The year. Now, I have written sonic sensors. So it can be any kind of like sound sensor. Basically, we use the ultrasonic sensor. I will be using it in future also, while we will be doing some projects, interesting, very interesting projects. Okay. Sonic sensors are there, which can detect sound, which can detect the distance by calculating the distance, by calculating the time. You have heard, you have like performed the operation in echo, right? Echo and speed equal to time by speed equal to distance by time, right? This basic formula, it can be used, okay, by calculating the time of reflection of sound, ultrasonic sound, basically. Okay, that's how the sonic sensors or ultrasonic sensors, whatever you say, they work, right? The limbs, the motors, basically the motors. Why I've written the motors? There are the motors, the wheels, which help a robot to move, basically. Okay, if it is a walking robot, the legs, the actual limbs, the legs or the arms, they help to walk, right? If it is a car type of robot, which I will be showing you some of the pictures in the future classes, definitely, then the wheels are the limbs which help in moving. So what is the basic purpose of me saying all these things? That human body or living body, not only human but living body, natural body, they inspire the build of a robot very much. You can say 100% it is built or inspired by the natural bodies of things. You see the eye, okay? If you see the structure of the eye, if you see the structure of a camera, and if you compare both of them, let us do that. Let us see the structure of human eye. If you see the structure of human eye, dear students, you'll see there's a lens over here, the lens, right? The convex lens over here, which converges the light rays, and it gets formed in the screen behind called the retina, right? It's called the retina. All right, understood? Clear? So this is highly inspired by the human body or the parts of a living or natural beings. So this is how the lens is working, basically. And lens is a very famous thing in our cameras and in everything. We know how it is being used and how to change the lens, how to change the focus of the lens, right? By changing the focus of the lens, the depth increases or decreases, might be. Okay. So there are different layers. There is the layer called, there is a hole called pupil, the opening, right? There is an opening or orifice called the pupil, from when the amount of light enters the eyes, and it determines how much the brightness is, or how much lesser bright the picture that is obtaining in our retina might be. Okay, iris is there, ciliary muscles are there, which controls the ciliary muscles basically controls the lens, the aperture of the lens, and iris basically controls the opening, that is the pupil. So iris is basically the master. Like, for example, if you are the master of your own room, you are opening and closing the window that much, so that much light can enter from the window. So imagine the window to be the pupil, okay, and iris becoming you. So you are the iris and the window is the pupil. So you can control the opening and closure of the window, the amount of light that is entering in your room. Same is the purpose of iris, to control the amount of light entering the eye. Okay. And it is very famous thing that when you enter a bright room suddenly, then your pupil gets smaller, right? To make the amount of light little bit less. Okay, right? Or basically you can close your eyes also. Okay, okay, that's the parts of biology that we have studied. Okay, so why I'm saying all this, why I'm saying, if you see, if you compare basically the basic structure of the human eye and a camera, what we have the shutter. You've heard about the term shutter speed, right? Shutter speed, you've heard about it. The shutter is basically, you can say, the eyelids kinds of thing, which you close like this. You're closing and opening, right? There's the lens, there's the diaphragm, okay, and there's the film, like retina kind of structure. See the similarity, dear students. utmost similar both the structures are. So they are inspired by the natural things. Again, one more. See, this module I will be showing you while building the projects also. It can be connected to the Arduino, as you can see over here, their wires are present. Okay. So the eyes we know, the eyes we use various kinds of cameras. Can you see? From a bigger camera to a moderate size robot camera. Nowadays, they can be used in house surveillance and things, to a very small camera that can be associated with the smallest microcontrollers also. Okay. Understood, dear students? I hope you have understood. Next, the auditory part. So this is the basic structures of the human eye, human ear. So let's not go into deeper into the study of human anatomy. What is the function, how it is functioning in a very simple language, dear students? Sound is getting accumulated by this helical structure of the outer ear. Sound goes in, it passes through the auditory canal, okay? And then it hits the tympanic membrane or the eardrum, what we call. So that's the membrane kind of thing, a sheet kind of thing, and sound waves are hitting it, right? So see, sounds are getting produced, right? Vibrations are getting produced. These vibrations are basically converted into electrical signals by this inner ear part, this cochlea and the vestibular nerve and everything. And then the nerve basically carry the information to the brain. So this is basically how the human ear works. Okay. Now, somewhat equivalent to the human ear, and not only human ear, the ear structure. Okay, the ears we know. You see, the microphone module to receive the sounds, the ultrasonic module, one of the most famous sensor, dear students. I will be teaching you how to build the projects along with the Arduino and other kind of microcontrollers. Then we'll be using these kind of sensors to build various and numerous amount of projects. Okay, we'll be seeing in the future sessions. Then comes the limbs. Okay, so limbs are very important, like to grab things, to write, to eat, to anything, to walk, right? Those are also hind limbs. Okay, these are the forelimbs, those are the hind limbs, legs. In limbs, what we need to observe is the very infamous joints over here, right? The shoulder joint is there, okay? The elbow joint is there, the wrist joint is there, the fingers, right? Carpals and tarsals. You don't need to remember the names of the bones, of course. Okay. What I need to show you is the structure, how it is made. Okay. So in the language of robotics, in our robotics language, what we will say, we'll say these bones kind of structure in a robot is what a link is. And obviously, when two links comes together, it forms a joint. Okay. So this structure where it joins, basically it's very easy to remember, where two links joins, basically is called a joint. All right. So these are the limbs we know for a typical robot. These are if you don't know what these are, no worries. In our further classes, we will be studying. In our further sessions, we'll be seeing what these are. These are the kinds of motors. Okay, we will be studying several motors, stepper motor, servo motor. We'll be studying them. Okay. Now, after studying all the parts and how they're inspired by the natural, either human parts or any animal parts and things, there remains one particular part which is of our utmost interest. As a student of the session of robotics, it must be of your utmost interest, dear students. What is it? The most important of them all, the brain. Without the brain, there is no commanding. There is no command. There exists no command in the natural body of a human being, of any animal, or in the body of a robot. Somebody needs to be there, something needs to be there, some sensor need to be there, something need to be there who can give a command and at a particular time, right? If you're thirsty, right, if your body needs water, your brain sends a signal that you need water, right? Your brain is everything. Without the brain, it's kind of a zombie situation, right? Okay, you've seen in movies, right, how zombies work. Okay, their brain are dead, basically. All their appetites are increased. So uncontrollable appetite, uncontrollable thirst, that's the logic behind it. So brain is the main part. And if we draw an analogy similar to the other parts, what we get, you see, the brain is basically the controller of or the instructor of the human body, right? It controls all the other organs or instruments that are functions by sending signals which are basically electrical in nature, right? Brain sends electrical signals. Clear. All right. Similar to the brains, what we have something called the control, or rather, in our session, we'll be calling it the microcontroller. So, what is the purpose of a microcontroller? Without the microcontroller, there exists no robot because it will just be parts assembled together. There will be no command. The instruction that we want to make the robot listen, we need to give it to the microcontroller in certain coding language. There comes the purpose of programming, right? There comes the purpose of programming. When we program the microcontroller, it understands the signal and then it sends those signals to the different parts of the robots. That is the importance of a microcontroller. Understood? I hope it is clear to everybody why we need a microcontroller. Now, what is this slide about? If you remember, I hope you have attended the first session. I asked you something about the father of robotics. Rather, if you have done the homework, basically, you will be understanding the father of industrial robotics. Okay, this is the picture of him. Okay, not this one. So this is a picture of him, Joseph Engelberger and George Devol. They are considered the father of industrial robotics. This was just an answer to your question that I have asked in the previous session. All right. So in this session, what we have learned? We have learned the basic motto of this session was to give you a very basic idea of the parts that we are going to study separately of a robot. And to make you understand a very simple concept that every part is inspired by our living beings, either human beings or any kind of animal. So it means, why I have included this session? Why do you think? To make you understand something, that whatever we want to build in a robot, whatever comes in your mind, that sir, we should do this, we should do that, we should build this, we should make this robot do this function, it already might exist in the natural world. You just need to observe it, and you just need to understand, you just need to comprehend how it works, and that is how you can make a robot do it. So this was all about my session today. Okay, this was all. I hope to see you in the next session, that is the third session, and we'll be continuing this with only focusing on the brain first, that is the microcontroller. We'll be studying it in a great details kind of things, because the introductory part are over. I think, I hope you have understand. I hope I could make you understand what is the purpose, why we need to do this, how we need to do this. Okay, so now we'll get totally getting into the how part, and we'll be covering all the portions from the microcontroller part to the project building. That's it, dear students. I hope you have enjoyed this session. Thank you very much. See you very soon with the third session.